Welcome back to the matrix. Today we will be plumbing the depths of matrices and learning how to use matrices in solving systems of equations. In this lesson we will be covering a lot of material. I highly encourage that you use the pause and rewind buttons for sections that you need to take a little bit more slowly or need to see over again. These identity matrices are basically filled with just ones and zeros. The ones are along the diagonal from the upper left hand corner to the bottom right hand corner, and everything else is filled in with zero. So what the identity matrix does for us is basically, if we were to multiply a matrix, any matrix we can call A, times the identity matrix, we end up with the original matrix A. So in other words, it's just like multiplying by the number 1 when dealing with real numbers, except this is the matrix version of that. And conversely, we can multiply I with A and still get A. But don't take my word for it. Let's actually take a look at this and see how it works. We will be multiplying to a 2 by 2 with a 2 by 2. Now hopefully you will are starting to be able to multiply matrices without the assistance of the slips of paper. By the time we get around to the test, we won't be using those. So let's go ahead and try this without the use of any aids. So we'll start off by multiplying 3 and 1, which will give us 3. Then 2 and 0, which will give us 0. 5 and 1 will give us 5 plus 4 times 0. Next we'll do 3 times 0, and then 2 times 1, 5 times 0, and 4 times 1. We simplify what we have, and that's going to be 3, 5, 2, and 4. And that's the original matrix we started off with. So we can see that the identity matrix actually does what it says it's supposed to do. Okay, now the next thing I want to talk about is inverse matrices. So let's say matrix A and matrix B are inverses of each other. If we multiply them together, you end up getting the identity matrix. That's what makes them inverses. So if I say A times B, that's going to give me the inverse matrix. And likewise, B times A would also give me the inverse matrix. We denote the inverse matrix as the matrix variable to the negative first power. That's how we generally indicate inverses, is to the power of negative 1. So let's try this out. So I have two matrices, a matrix A and a matrix A and a matrix B. We'll call the first one matrix A. So this is A and this one's B. So hopefully if we do this right, we will get matrix I. So let's start off. 3 times negative 5 gives us negative 15, and 8 times 2 is 16. 2 times negative 5, negative 10, and 5 times 2 is positive 10. Next, 3 times 8, which gives us 24, and 8 times negative 3 gives us negative 24. Then we're going to do 8 times, let's see where now we're going to do 2 times 8, which is 16, and 5 times 3, which is negative 15. Alright, so let's see what happens. So this gives us 1, and then 0, and 0, and 1. And lo and behold, we have the identity matrix. So A and B are definitely inverses of each other. Okay, so since we know what an inverse matrix is, how do we find it? Well, let's say we have a matrix A, B, C, D. We can find the inverse of A to the negative 1, as 1 over the determinant of A times, and then we take our original matrix and D and A, well, A and D will flip places along the diagonal, and then the C and B we will make negative. So we modify the original matrix and we multiply that with 1 over the determinant. So recall that the determinant is AD minus CB, and then when we get that 1 over determinant, that's going to become a scalar. Our scalar, in fact, that we multiply with our modified matrix, thus giving us our inverse matrix. So let's give this a try. Okay, so let's say I want to find the inverse of this matrix A. 5 times negative 2 and 8 negative 3. Not times, but it's a matrix. Okay, so the inverse of A is found by 1 over the determinant of A. So that's going to be 5 times negative 3. So it's going to be negative 15 minus 8 times negative 2, which will give us negative 16, which turns into positive 16. We're going to multiply with our modified matrix, so we're flipping A and D, so negative 3 here, 5 there, and changing the signs here. That becomes negative 8, and B becomes positive 2. Okay, let's go ahead and simplify this. This becomes 1 over 1, so just 1, and negative 3, 2, negative 8, and 5. And lo and behold, we have our inverse matrix. So inverse of A is in fact, so the scalar is 1, so that's going to make it real easy for us. 8 and 5. So depending on what your scalar is, it can become really easy to use, or it could be a little bit more of a challenge. It just depends. Sometimes you get weird fractions, sometimes you get whole numbers. In this case, this first one, it was really nice. Okay, so we know what an inverse matrix is. Why would we want to use it? Well, let's say I want to solve for a matrix X. Okay, well, I have this equation of matrices, matrix A times matrix X equals matrix B. So kind of like if we were to say, some number times X equals another number. But we're just doing it with matrices. How do we solve for matrix X? Well, it works the same way with matrices, in a sense, as we do with deal with real numbers. We want to isolate our variable. And in this case, we want to isolate our variable matrix. So how do we do that? Well, normally you'd think, well, I'm going to divide by A on both sides, and then I got it. But we're not doing any matrix division. So what do? Well, we got to get rid of the A. And to do that, we're going to multiply by the inverse of A. So the idea is this. Here's matrix A, here's matrix X, and here's matrix B. So we want to multiply both sides by the inverse of A. The inverse of A. Okay, remember what you do to one side, you do to the other. Well, matrix A and the inverse of A, as we just learned, gives us the identity matrix, I. So we'd be left with I identity matrix times the variable matrix X, and then B, and then times, and then, well, actually, I made a mistake here. You have to be careful. You have to be careful about how you multiply your matrices together, because it's not commutative. So really, I can't put my inverse in the back. I have to put my inverse in the front. So in fact, it's going to be the inverse of A times matrix B. Otherwise, you're not going to get the correct solution. So here we are, the inverse of A times B. Well, then the identity matrix times any matrix gives us that. So we're left with the variable matrix is in fact equal to the inverse of A times B. So with that concept in mind and how this works, it becomes very easy for us, in a sense, to solve this. But the first thing we have to do is find our inverse of A. So this is matrix A in front of the X.